Hey, we're going to look at how to do looping within Python. This is a very important topic regardless of the programming language you're using. You typically, within a programming language, need to know how to do things over and over again. Let's say, for an example, why we might need to loop. Let's say I needed to print, I want to encourage someone, so I'm going to say, let's go. All right, so I'm going to say, let's go. I want to print that. Okay. Let's say someone needs a lot of motivation to really go, so you need to do this multiple times. So I'm going to say, let's say we have to do this 5 times. You know, some people need a lot of motivation, so we're going to do this 5 times. So this would be very tedious for me to just continue to type let's go over and over again. Yes, I could copy and paste it, right? But this would be boring and tedious. And if I wanted to change my message slightly, let's say I want to do caps because that's really encouraging. Let's go. But now I have to change that everywhere. All right, so you can see how this would be bad, right? So if I know I wanted to do this 5 times, let me just take this. I can use a for loop. Let me cut this for now. So I can say for, then I have to say some variable name. So I can say, let's just call it count. So I can give this any variable name, and then I can say in a range. So a range is a range of numbers. And within there, I can say, what range do I want to stop at? So I want to, and by default, it's going to start at 0. So let's say I want to go to 10. I want to say this 10 times. I can say for count in range 10, and then I can say print let's go. Now notice a few things here. Starts with for, some variable name, in, and then I do this range and how many times I want to do this loop. And notice it ends with a colon, and then the things I want to do inside of this loop are indented. And let me show you what I mean by that. So to start our program, I'm going to say print start, and then I'm going to say print end at the very end. Okay. So we should see start 1 time and end 1 time. So start at the very beginning, end 1 time, and then we should see let's go 10 times in the middle. And notice how this is outdented, meaning it's out here. The thing that's in the loop is indented. All right, so let's run this and see what happens. All right, so see we got start, then we got let's go, and then end. Right. So what happened is it came in here, and because of this range, it looped 10 times. Boop, boop. And to make it more clear, let's, instead of printing the let's go string, let's print this count so you can see what range is actually creating. Because sometimes you might need the number that it is counting through, going through. So I'm going to print count. What you'll notice, we started at 0 and went to 9. You might say, well, why is that? I kind of expected 1 through 10. Most programming languages, when you're dealing with lists or collections of things, they start at 0. And that's the same here with this range. So range says start at 0 and go to, but do not include this number. So if I say range 10, it's going to loop 10 times, but it's going to start at 0 and go to 9. So that's obviously 10 times, right? So 0 through 9 is 10 loops, 10 what we call iterations, 10 loops through. So just realize range is where how many times you're going to loop, but it's going to start, the actual value is going to start at 0. So, and notice this variable name can be anything. So let's say I change that to X, and let me run it like this, and it should error out. Yep, it's going to error out. And it's going to say, I don't know what count is anymore because this variable is named X. So I'd have to change it in here as well. So there we go. So let me close this. Now this should work just fine. All right. If I wanted to change this to num, like for short for number, I could do that as well. It doesn't matter. So you're going to say for some variable in range, you put the value, how many times you want to loop, colon, and then do your work inside of here. And I can do multiple things in here if I wanted to. Print hello. So, but everything I want to do inside the for loop has to be indented at the same level. All right, so there we go. So now I've got print start, that's beginning, right? And then in the side of the loop, one's hello, or sorry, 0 hello, 1 hello, 2 hello, so forth and so on. All right. So let's say now, I mean, if I wanted to do this 100 times, I could do that easily, right? Change this to 100, boom. Now I looped 0 through 99. If I wanted to actually stop at 100, let me take this hello statement out. If I wanted to stop at 100, 0 to 100, I could actually say 101, right? So it would go up to 100, but not include 101. So it'd be 0 through 101, not including 101. So if I scroll all the way up here, you see we started at 0. All right, that's great. But let's say I want to go backwards. Instead of going from 0 to, or yeah, before we go backwards, let's actually keep going forward. But let's say I need to go 50 to 100. I could actually tell it the starting number. If I don't, these are called parameters. The parameter I passed here, if I pass one parameter, so just one number in here, that is the stop value, where it's going to stop at, but and not include it. So we've been just adding the stop value. But I can also add in front of here, I can add the start value. So let's say I want to start at 50. I can do 50, 101. Now, if I run this, you see if I scroll up here now, we started at 50, not 0. So we went 50 to 100. All right, that's good. Now, this is a lot of numbers. Let's say I wanted to go from 50 to, well, you know what, let's go up to 75. How about that? 75 to 101. So I can put any start number in here I want, and then it'll go from there to the last number. Well, now let's think, what if I don't want to show all the numbers, but I want to show all the multiples of 5, or I want to count by 5s is another way. I can actually add a third parameter that says what to count by, or they call it the step. So we've got the start number, the stop number, right? And then the third parameter is the count by, or the step. Start, stop, step. So if I run this, we're going to start at 75, then we're going to add 5, which would be 80. Then we're going to add 5, which would be 85, 90, keep going. All right, so we did 75, 80, 85, 90, 95, 100. There we go. So you notice we counted by 5s. So it's start, stop, and step. So I could change this if I wanted to count by 2s. I could do that as well. So I start at 75, and 77, 79, 81, so forth. That'd probably be better if let's say I wanted even numbers. I could start at 74, count by 2s. There we go. So it's start, stop, and then the step. So if I wanted to go backwards, let's say I wanted to go from count from 10 down to 0. I could say start at 10, stop at 0. Okay, let's say we want to go 10 to 1. Or say stop at 0, because this says stop but don't include. Now, in order to go from 10 to 0, I have to count backwards. How do I indicate that? Well, I actually say my step is -1. So -1 says start at 10, then step, -1, which would be 9, and then keep going until I get to 0, but don't include 0. So I run that, I go to 10, down to 1. Now, what if I actually did want to include 0? My stop would have to be -1 in this instance. So it's going to keep going backwards, negative numbers, right? So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then 0. And then in order to print 0, I have to make this -1, which says go to -1, but don't include it. And there we go, 10 through 0. And again, you can increment even backwards by other numbers, or you can, when I say increment, I mean step. So there we go. So from 10 down to 0, stepping backwards by 2s. So the range allows you to specify the start, the stop, and the step. So really powerful things that allow you to loop. If you know the amount of times you need to loop, you can do that with a range. And again, if you just want to go forward 20 or step 20 times, you can always, if you know just one number of times you need to do something, you can just put that number in here. So again, like if I just wanted to say, let's go 20 times, this would be super simple. But I wanted to show you those other values with using this variable so that you can do more interesting things. So that is a for loop. For loops are, if you know the number of times you want to loop, really powerful to do that. What if you don't know the number of times you want to loop? Well, that is where a while loop comes in. A while loop allows you to loop until some condition is true. Or sorry, is false. You loop while some condition is true, and so you keep looping until that condition is false. So let's do a simple, similar to what we did in the while loop. Let's have I'm going to create a count, and I'm going to set it to 0. Let's say we want to keep looping while count is less than 10. So what you do with a while loop is you say while, and then you give it some condition that has to evaluate to true or false. So count less than 10 is either going to be true or false. So this is a valid, what we call expression. Then I have to say colon, just like in my for loop. And if I hit enter, notice it's going to indent. It's going to tab me in here. So now all the lines that are indented are part of the while loop. So I can say print count, oops, and then to make count increase, so I don't loop forever, right? If I ran this right now, it would loop forever because count is going to be 0, and it's going to check is 0 less than 10, yes, so print count. Then it's going to come up here, is 0 less than 10, yes, print count. Is 0 less than 10, print count. So a while loop keeps going. It does whatever if this condition is true, it goes into the while loop. And then once it finishes what's in the while loop, it comes back up to check if that condition is still true or not. If it is still true, it keeps going. So in order so that it doesn't loop forever, we're going to say, let's increment count, mean basically add 1 to count each time we go through. So the way I can do that is I can say count equals. So that means whatever I do over here on the right side of the equals, put that value into count. So I'm going to say, hey, take the existing value of count, which starts at 0, add 1 to it, and then store that into count. So this is going to come through and say count is going to start at 0. 0 is less than 10. Yes, it is. So print 0. Then it's going to say take the value of count, which is 0, add it to 1. That becomes 1, and make that the new value for count. Comes up here, 1 is less than 10, or it checks if 1 is less than 10. It is. So it prints 1. Then it takes the value of count, which is 1, adds 1 to it, which is 2, and puts that back into the count variable. So now count is 2. So this will print from 0 up to 9. Here we go. So start 0 to 9. And if I want to go to 10, I could increase this to 11. So 0 up to 10. So the idea here is that this condition has to be evaluated to true or false. And it's going to check it every time. Now this, if I wanted to get this result, I wouldn't do a while loop. I could just do a for loop. It'd be easier because then I wouldn't have to worry about incrementing or adding to count every time. It would do it for me. But a while loop is important if you have some condition you want to check. So maybe I am writing some code that waits for a button to be pressed. So I can have a variable, let's call it button pressed, and I could say it's true. So basically, maybe you only want to do something while a button's pressed. So I can say while button pressed, and here's something. You can use double equals if you want to check the value of something if it's equals. I should probably go back and show you that with count. Let me do that real quick. Let's go back to our count example. So I did have count was less than 10, right? So this would be 0 through 9. Another thing is I could say, yeah, if I said, ooh, while count equals 0. So only do this while count equals 0. Now, of course, this time it's only going to run once, right? Because count does equal 0 at first, and it's going to print 0, and then it's going to add 1 to count, and then count will no longer equal 0. So if I run this, we run the loop one time, all right? But the key here is I want to show you this double equals. Double equals is a way to check if a value is the same as another value. The issue is if I tried to use a single equals, this is what we call an assignment operator. It will try to assign this value into the variable. So don't use single equals if you're checking if they're checking. We call it checking for equality. You use double equals if you're checking for equality, not single. So that's the way you do that. So now let me go back to my button pressed example. So I could create a variable called button pressed, and I first start that out as, let's say we start out as true. So we're only going to do this thing down here while the button is pressed. So I could say while button is pressed equals true. Then it's going to do this. Now count doesn't, and I could maybe just print out the fact that the button is pressed. And in this condition right now, it would loop forever because button is pressed equals true. And it's going to check is button pressed equals true, or while button pressed is true, keep doing this. What I'd have to do is have something in here to change button pressed. So I could have some function. So normally if you're working with a microcontroller like Raspberry Pi Pico, you would check the pins to see. And I could say check button. So I could have a function like that that checks the button, and then it could return true or false. So let me do that. So let me define a function up here. Def check button, and it could return, what actually if the button is pressed. I'm going to hard code it and just say false for now. So basically this is going to loop one time. So let's try this. So see, button pressed was printed out one time because we initialized or we started button pressed variable as true. It said while button pressed equals true, then print button pressed. Then we would say check button, call this function called check button. And in here is where we would do the logic to actually check if a button was pressed and return, true if the button was pressed or false if it wasn't. But in this case, I'm just hard coding it to false for this example. So this says return false, so then false gets put into button pressed. It comes up here. Button pressed is no longer true, so this fails. It becomes false, and it exits out. All right, so that's why we're only going to do this one time because we immediately changed it to false. But now, in your case, if this method or this function was actually checking if the button was pressed and you held down the button, and it could return true for that time, it would keep saying button pressed until you let go of the button. So I'm going to show you one other thing, just a shortcut. If this is we call this type a Boolean. If you read the chapter in Python Hello World book about types, you should know there's a Boolean type, which is true or false. Boolean can only be true or false. And this while loop needs to have this expression or something here that evaluates to true or false. If you're already using a Boolean type, you don't need to say equals equals true. So this is a shortcut in a way you see it written a lot. You can just say while button pressed, and if button pressed is a Boolean, that means it's either going to be true or false. So while true, do this, or while false, it's not going to do it. So I can take out the equals true and run this, and it works exactly the same. That's because I'm using a Boolean already. So whatever I have after that while and before the colon has to be able to evaluate to true or false. And since it's a Boolean, it is either true or false. So you could write it if it makes more sense to you, if it's easier to read as while, while button pressed equals true, and that's perfectly fine. I have no problem with making more code slightly more verbose, meaning more words, if it's easier to read and understand. So of course, that's not what I'd want in my case here, say while true. You could flip this around. If you wanted to keep looping until the button was pressed, you could do that as well, right? So let me just switch it all around. So this can change based on what you want. What I mean is, so let's say my logic, I want my logic now to keep running until the button is pressed. Or sorry, yeah, I want to keep running until the button is pressed. So once the button is pressed, so check button returns true, I want it to stop. So in that case, I say while button pressed equals false. I'll say now button not pressed, right? So I want to keep doing this while the button is not pressed. So this will work one time again as well, because my check button is changing the value to true now. But so if you want something to equal false, you can do that. Now in this case, I couldn't just say this would not work in my condition, right? Because it would say button pressed is false. So while false, okay, whoops, it's going to stop immediately. It's not even going to execute this, right? So it's not even going to execute. So in this case, I do have to do equal false, because I want it to only run while the button is not pressed. So button pressed equals false. One last thing I want to show is that with the while loops, you can, if you wanted to loop forever, you could simply say while true. And so if I said while true, you can say forever. So anything you want to do forever, you could put in a while true block. Now if I run this, I don't need this anymore. So I don't need that. So I'm going to loop, and it's just going to run forever until I kill it by stopping it. This is valuable, and you see this a lot when you're dealing with a microcontroller. So you want something to happen over and over and over and over again. So you just want to keep doing whatever you have in this block forever. So in this case, it would never get to my end. It would never run any code after the while loop. Anything outside of the while loop, it would never run it, because it's going to loop forever inside of here. And again, there are a few scenarios like with microcontrollers when you need to do something forever. So maybe you're writing a sentry gun program and you need something to you need the sentry gun to constantly do something forever until you turn it off. You wrap that in a while true loop. And that's it.